answers for some select multiple choice problems in this packet. Let's go ahead and take a look at problem number 9, 10. Who said 9? Whoops, not bad. Hold on. There it is. Okay. So we're going to do the integral from 0 to 1 of e to the negative x dx. For integrate, we need the derivative of the inside, sit in those parentheses. The derivative of negative x is negative 1, which means I need a negative 1 on the outside. I can now integrate. The integral of e to the something is e to the something times that negative 1 from 0 to 1. And then I substitute in, I get negative 1e to the negative 1 minus negative 1e to the negative 0. Okay, so let's see what that does for answers for us right here. E to the negative 0, this is 1. 1 times a negative is a positive 1. So if I were to guess right now, I'm going to guess A. Now I have to figure out what this part is equal to. E to the negative 1 is 1 over 8. Times, that's a 6. Who wrote a 6? Michael, you messed it up on me, buddy. The negative sign on there, so the correct answer for part 10, question 10 is 1 minus. Okay, so now let's take a look. Let me slide this up. There we go. Let's take a look at number 11. 11's got a couple different things going on with it. So what I'm going to do, write my integral sign down. I'm going to look, this is my inside function. What's the derivative of the inside function? The derivative of the inside function is 2x. Okay, so I need an x just lying around. I have one. I can put that in parentheses. I also need a 2. If I add a 2, that's counteracted with a 1/2. So I'm integrating e to the something. And the integral of e to the something is, I keep the 1/2 with me, e to the something, from 0 to 1. So I'll sub those values on in, and I get 1/2 e to the first minus 1/2 e to the 0, which is equal to 1/2 e minus 1/2. So I'm going to look and see if I see an answer that looks like that. Well, I believe it's this one, because if I distribute the 1/2 over, I get choice B. 2 more right now. Let's try number 13. So 13, no fractions, no radicals. So if I bring this up, it would go up to the negative first power. So I'm going to leave that down below. Move the dz out to the side. This could be an ln problem. The derivative of the bottom would be negative 1. So I'll put a negative 1 in here, counteract it with a negative 1 on the outside. And the integral of something, 1 over something, is the ln, lots of lines, the absolute value of that something, from 1 to 2. I'll substitute on in, and so I get the ln, I'll keep the negative 1 outside, ln of 3 minus 2 is 1, ln of 1, minus ln of 3 minus 1, which is ln of 2, close parentheses. So I'll distribute that minus sign, so we've got negative ln of 1 plus ln of 2. I'm going to look at my answers, and I don't see that anywhere. Well, what I do know is that the ln of 2 things added is the same as the ln of 1 thing multiplied. So 1 times 2 is 2. And now I have an answer. So our last problem will be 23. First rule, no fractions, no radicals. If I brought this up, though, I'd be bringing it up to the negative first power. So we have to hope this is an ln problem. I'm going to write down 1 over e to the x plus 1 dx. The derivative of the bottom is e to the x. I need an e to the x just lying around to have one. X just lying around. So now we double check. And is that we double check. First we check we have 1 over something set up. The derivative of the inside, e to the x, is sitting right here. Means I can integrate. I get rid of this. Just forget about it. It's gone when it integrates. The integral of 1 over something is ln, the absolute value of something, from 0 to 1. We'll go ahead and fill those on in. So I get the ln of e to the x, e to the 1, plus 1. And get rid of the parentheses because everything there is positive, minus the ln of e to the 0, plus 1, which is the ln of 1 plus e. Michael made a small mistake. There should have been the ln of e to the 0, which is ln of 1 plus 1, which is ln of 2, which makes this 2, which gives us our correct answer. And right there. Okay, good work. I'll see you guys tomorrow.